Naming alkenes and alkynes. So for naming anything, there's the general form of prefixes, the parent, it's the longest chain, continuous chain, and the suffix. Prefix, that tells you the name of the group that is a branch off of the parent and where it is. For example, here that's a methyl group. Here this is an ethyl group. Anything that's not contained in the parent chain. And then the parent is the longest continuous carbon chain. 1, 2, 3, 4. 1, 2, 3, 4, 5. 4, 5. So just the longest continuous chain. And the suffix tells you what type of chemical it is. So for alkenes, they have an ENE ending. If you know the name of the functional group, the ending's the same. Ene for alkene. Then if you have an alkyne, it has YNE ending for an alkyne. So notice they share the same last three letters. So the suffix tells you that it's an alkene or an alkyne or an alkane from back in chapter 12. But in this chapter, the parent must contain the double or triple bond. So, double bond for an alkene, triple bond for an alkyne. And the location is minimized. So that takes precedent over the location of any substituents, any methyl, ethyl, propyl groups. The parent's got to have the longest chain, or the longest chain's got to have a double or triple bond in it, and the numbering is going to be such that you're going to try to make that bond location as low as possible. Examples. Good practice. This structure, I'm going to convert it into a skeletal structure. I'll do that by numbering the longest chain. So it's got to contain the double bond. 1, 2, 3. So methyl here, methyl there. So since it's the same, I could go either direction. Just for simplicity's sake, I'm going to just stay in a row. 1, 2, 3, 4. One, 2, 3, 4. So I'm going to draw a zigzag. 1, 2, 3, 4 carbons. 1, 2, 3, 4. I look back up. I've got a double bond between carbons 1 and 2. So 1, 2, 3, 4. So 1, 2, 1, 2. Then carbon 3 has this methyl group bonded to it here. I know it's drawn up here, but molecules can spin, twist, rotate. The proper way to draw it would be down. This is a down carbon. It's down in the valley. Move downward. So there's the structure. So the longest continuous carbon chain containing the double bond is 4 carbons long. So that is a butyl or butane, or buta is the prefix for it. But since it's an alkene, the double bond, and the starting position of the double bond is here, carbon number 1. The parent name is 1-butene. The 1 is needed to say that the double bond starts at carbon 1. And then carbon that's not numbered, that's a substituent, that's a branch hanging off of it, is a methyl group. It's on carbon number 3. This is 3-methyl. One butene. 3-methyl 1-butene. You can do the same thing for the alkyne to the right. I'm going to number it. 1, 2, 3, 4. And then at 4 there's a branching point. But again, the same carbon distance, 2 and 2. So which path I go here, since they're equal, 5, 6. It's the longest continuous carbon chain that's got the triple bond in it. The zigzag's a little different than an alkene. Remember, a triple bond, the geometry is linear, it's straight. Draw the triple bond first. One, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Between 2 and 3 is the triple bond. That's not drawn in a zigzag because of that linear geometry. And then on carbon 4 there's an ethyl group. 4 to 4. And that's the structure made into a skeletal structure. So the parent here, 6 carbons long, is 2-hexyne, to say that it's an alkyne, the YNE ending. And then on carbon number 4 is that ethyl group. So this is 4-ethyl 2-hexyne. And the 2 tells you where the triple bond starts. When it comes to naming alkenes that have more than one double bond in them, here there's 2 double bonds, well, in both of the molecules. The rule is that you still want to minimize the numbers of where those double bonds start. So it's the same kind of idea, but you have to say that it's a diene or a triene or any of that. So di tells you that it's 2. So if it had a tri here, that would mean that there would be 3 double bonds and so on. You just have to provide a number for the location of each of those double bonds. So this first example, I'm going to number 1, 2, 3, 4, just to check myself. 1, 2, 3, 4. Whether I go from left to right or right to left, 1, 1, okay, that number is the same, and then that's where the double bond starts. Then the next one, though, 1, 3, 1, 3. So 1, 3 is as low as you can go, numbering from right to left or left to right. So what this would be is 4. There are no substituents hanging off of it. This would be 1, 3, buta, since they're double bonds, diene. Since there are two double bonds, diene. So di is needed to tell you that there's two double bonds at 1 and 3. Tri would be used if there were 3, and so on. That's that compound's name. Here, the next example, 1, 2, 3, 4, 5, 6. Number from right to left. At this branching point, 1 carbon, so I just kept it simple and went this way. 1, 2, 3, 4, 5, 6. So the double bond takes priority over the substituent. So that methyl group's not been numbered, they're just circled. So here, 1, 4 is lower than 2, 5. So the correct way to number this is right to left. So 6 carbons in it. This is going to be 1, 4 hexa, 2 double bonds, diene. And that di before the ending, ene, tells you that you have 2 double bonds. And then on carbon number 5, there's a methyl group. So 5 methyl, 1, 4 hexa diene is how you would name that diene. So naming cycloalkenes, cycloalkenes, and that ene ending tells you got a double bond in there somewhere. You would use cyclo for the parent to say that it's cyclic, that it's a ring structure. But again, the goal is to minimize the locate numbers, the numbers for the double bond. That's priority 1. That takes priority over the substituents here, here, and here. Just to give an example, remember this 1, 2. Okay, you have to pass through the double bond. In other words, it would be wrong to number this 1, 2, 3, 4, 5. Once you pick 1, your next carbon is the other end of the double bond. That rule, you've got to pass through the double bond. Here, you've got to pass through the double bond. But position 1 both minimizes the location of the double bond and the substituent. So this would be 1, methyl cyclo pentene. So 1, 2, 3, 4, 5 carbons. Penta is 5. Cyclo is used because it's in a ring. And the E ending is used because it's an alkene. Now the next example, 1, 2, 1, 2. I mean, those are the options. For a ring, you always start at a 1, just for the double bond. Just by the ring, it's just 1 is the default number, and that's why I didn't include a 1 here, because for a ring, 1 is the default number for the location of the double bond. But with this numbering scheme, I would have 2-methyl, 3-methyl, here 1-methyl, 6-methyl, and we'll just go ahead and fill in those numbers. So the red scheme, 1, 2, 3, 4, 5, 6. The green scheme, 1, 2, 3, 4, 5, 6. Those are the numbering options. So the double bond's got to be 1 and 2. The red one is the, would have 1, methyl, 6-methyl, the green scheme would be 2-methyl, 3-methyl. So the rule with cycloalkenes is you just focus on minimizing whichever scheme gives you the lowest first number. So 1 is lower than 2, therefore this takes priority over the green numbering just because it has the lower number. In chemistry limbo is how low can you go. Now it's hokey, but minimizing the number is always the path that you choose. So the name of the molecule above is 1,6-dimethyl. It stays the same because there's 2 methyl groups, dimethyl. Cyclohexene. Don't have to put the 1 for the double bond because it's assumed or omitted in cyclic alkenes.